So now that we've built the unit circle, let's take a moment to start looking at the patterns that are there, and let's take a look at how we're going to use it. How do you use this information now that we have it? Well, let's just remember what we know. In the past, our radius was defined as the square root of x squared plus y squared. But now we know our radius is 1, so it gives us a little bit better information. The point that we land on the circle, the x, y that we land at the circle, the x gives us our cosine, the y gives us our sine, and then the tangent is y over x. We still are going to use our reference angle to help us determine what the sine, the cosine, and the tangent are. But now it's going to require us to use a little bit more memorization to pinpoint those locations. Now we're going to take the information from the unit circle, and we're going to put it into a chart to try to organize the information even more. So let's take a look at this chart. Now, for the sine, mark that that's equal to the y. The cosine is equal to the x. The tangent is equal to the y over x. Those are pieces of information you would also have to have memorized. Now, see, you'll notice that our 0 through 90 has a little equal to next to it. That's for us to rewrite it in radians. So this is 0 radians. 30 would be 30 pi over 180, which is pi over 6 radians. 45 would be 45 pi over 180, which reduces down to pi over 4 radians. 60 is 60 pi over 180, which is pi over 3 radians. And then 90 would be 90 pi over 180, which is pi over 2 radians. There's not a super clear pattern there, but one of the things you might notice is 30 and 60 are halves of each other, and so their fraction doubles. 45 and 90 are halves of each other, their fractions double. Look at the denominators. The denominators keep getting smaller as we go up. There's just a few little patterns there. Now let's take a look at how we want to find or fill in this chart. So we are just, you'll notice that this is the first quadrant. If you memorize the first quadrant, you can develop any other quadrant that you want because the first quadrant's values repeat in every quadrant. The only difference is in other quadrants you get some negatives involved. Now, this is the easiest way, I think, to memorize this pattern. So the sine starts at 0 and finishes at 1. The cosine starts at 1 and ends in 0. So that's kind of the first pattern you want to remember, that the sine starts at 0 because that's your height, and as you rotate around the circle, it ends up at a height of 1, that highest point. Cosine starts at a length of 1, the x value, and keeps getting smaller and smaller and smaller as it travels to the y-axis. Now, what is in between that? Well, here's how you discover the pattern. This is square root of 0 over 4, which is still 0. This is square root of 1 over 4, square root of 2 over 4, square root of 3 over 4. Make that one look a little nicer. Now, a few of those, and the last one is square root of 4 over 4. Those can reduce. Square root of 1 over 4 is just 1/4. Square root of 2 over 2 can't. Square root of 3 over 4 can't. Square root of 4 over 4 can't. Okay? Now that you have that pattern, you just want to turn it around for the cosine. Just so where the sine goes 0 to 1, the cosine goes 1 to 0, so it's backwards. So now that you've done the work for the sine column, just turn the row upside, or the column upside down. And so that's 0. And I'm sorry, this one's square root of 1 over 2. That's 1/2. Oop. Sorry about that. I was thinking of the number 4. And they're supposed to be all over 2. Yeah, I'm sorry about that. I've lost it. Square root of 0 over 2, square root of 2 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. There we go. I'm so sorry. Okay, now that we fixed that. So now if we go and change that around, this is square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, sorry about that. That went very horribly. Anyway, so we're going to go from 0, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. For cosine, it goes from the bottom up. 0 at the bottom, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Okay? Now, here's the next part. You want to think about the fact that the tangent is y over x, or sine over cosine. So we're really just dividing those to get that. And let me kind of put that up here. So we would divide these two values, and it will get the tangent. I do not want them divided in such a way that you give me a decimal number. I want the exact answer. It will contain possibly radicals. I just want things reduced as much as possible. So the first one would be 0 divided by 1, which is 0. The second one, now how do we deal with this? Okay, so I'm going to do it down at the bottom here. This is 1/2 divided by square root of 3 over 2. Now, if you recall, we have dealt with complex fractions. And if you multiply the outer 2, that gives you the top. If you multiply the inner 2, that gives you the bottom. Both the outer 2 and the inner 2 both have the number 2 in them. Since the outer 2 and the inner 2 both have the number 2 in them, we can cancel out a 2. And so if we cancel out the 2's, on the top we have a 1, and on the bottom we have a radical 3. Now we don't usually leave it 1 over radical 3. You should rationalize it to be radical 3 over 3. Let's take a look at pi over 4. And again, I'm going to do the work down at the bottom. For pi over 4, that would be square root of 2 over 2 divided by square root of 2 over 2. Now what's nice about that is you're dividing something by itself. Anything divided by itself is always 1. So to find the tangent for any of your 45-degree ones are very nice. It's either going to be 1 or -1. Now let's do 60 degrees. For 60 degrees, that's going to be radical 3 over 2 divided by 1/2. Now let's think about our multiplication of those two things. You're going to flip the bottom one over, so it's going to be the outer 2 are going to multiply, the inner 2 are going to multiply. You'll notice they both still have 2's, so the 2's end up canceling. This time we end up with a radical 3 on the top and a 1 on the bottom, which is just radical 3. Finally, 90 degrees. That would be our sine value of 1 divided by our sine or cosine value of 0. 1 divided by 0 is undefined. So you either need to write undefined Now that we've seen this pattern for the first quadrant, You can use these patterns for all the other quadrants. Just remember you're always looking for how far away from the x-axis you are. Let's look at using these to answer some questions. So here they're saying to find the exact value of the sine of 4 pi over 3. So for the first time, we don't want to enter these into our calculator. Before, if it said the sine of 30, the sine of 40, the sine of 26, we would throw it into a calculator. We want the exact values. Now, the key here is that a 3 is in the denominator. Pi over 3 is 60 degrees. This is a reference with 60. Now, I don't particularly care for doing my work in radians. It's usually better to flip it to degrees because you can visualize those degrees because you've used degrees so often in your life. So if pi over 3 is 60 degrees, 4 pi over 3 is 240. So we can think of this as the sine of 240 degrees. Now, let's draw that on our unit circle for a moment. We already said that that was the 60-degree reference in the third quadrant, so it's negative, negative. But let's figure out what the point is. The point, do you notice how this length down here is shorter than your y value? The x is littler than your y. That's the way I always remember. Which one's going to come first, the square root of 3 over 2 or the 1/2? Well, the littler one is the x. So for reference here, that's negative 1/2, negative square root of 3 over 2. So that's the point at 240. Once you know the point at 240, remember you're going to use your y value is your answer. So the answer is negative radical 3 over 2. So what's the hardest part? The hardest part is, okay, where am I at? What's the reference? What's the point? Bam, as soon as you know the point, you know your sine, cosine, tangent, whatever value they're looking for. Let's look at 150. 150 is right here. It has a reference angle of 30 degrees away from the x-axis. So you got to think about what was your 30, except in this quadrant it's going to be negative, positive. The 30-degree point in the first quadrant was square root of 3 over 2, 1/2. The only thing that changes in the second quadrant is your x is a negative. So now we found what we need. So the tangent of 150 is the y value over the x value. Now, for your ones like this, the 2's cancel. We are left with 1 over radical 3, which I want you to rationalize. So your answer would be radical 3 over 3. And I forgot one little piece. This was a negative, so this is a negative, and our final answer is a negative. The tangent is always negative in the second quadrant and in the fourth quadrant. The tangent should always give you a positive value in the first quadrant and the third quadrant. So be careful with that. Don't make the mistake I almost made there. Let's do our last one. You'll notice for our last one, our denominator is a 4. That should tell you, hey, I'm related to that 45. That's square root of 2 over 2, square root of 2 over 2. But what am I? Well, 15 pi over 4s. Let's draw a little picture. I'm going to break these quadrants into 45-degree chunks. So when we were building the unit circle, the green lines, I'm breaking it down into 45-degree chunks. And let's think about where 15 of that takes us, because I have to go 15 pi over 4s. Okay, so I'm just going to rotate around the circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 pi over 4s is the same as our 45-degree location in the fourth quadrant, and that is the same as 7 pi over 4. Now, if you want to change it all to degrees, feel free to do so, but that's the same as 7 pi over 4. That point is a 45-degree point. It's a square root of 2 over 2, square root of 2 over 2. The only thing you have to discover is, what is it? Is it positive, negative, negative, positive? What are the arrangement of the points? Well, that point is going to be positive square root of 2 over 2, but it goes down to negative square root of 2 over 2. Now, as soon as we know the point, we can answer the question. So the secant of 15 pi over 4 is the same as the secant of 7 pi over 4. So it is the flip of the cosine. So the cosine would be square root of 2 over 2. Just flip it upside down. It's 1 over that value, or the reciprocal of that value. So put the 2 on the top and the square root of 2 on the bottom. Now, we don't leave things like that. We have to rationalize things like that. So let's multiply by square root of 2 on top and bottom. We get 2 radical 2 over 2. And it just so happens there was a 2 on the top that can cancel out with the 2 on the bottom. So our final answer would be radical 2. So that's a little fact you can remember, that the reciprocal or the flip of radical 2 over 2 is just a plain radical 2. That will always happen like that. Just sometimes it might be positive and sometimes it might be negative. Let's keep going and doing a few more. Let's look at these ones. What do I notice? Oh my goodness, I've got a 6 in the denominator. That's related to 30 degrees. So I know this is going to land me in a spot related to 30 degrees. Okay. But where? Where does it land me? Well, if you do not like, radians, feel free at any time to convert it to degrees. If we can convert it to degrees, a pi over 6 is 30, so 7 of those is 7 times 30, or 210. So we're really looking at the sine of 210. So in our memory banks eventually, we will remember that 210 is down in the third quadrant. The point at 210 is the point negative square root of 3 over 2, 1/2. For the 30s, the x is always bigger, the y is always littler. So that's why the square root of 3 over 2 comes first and the 1/2 comes second. And in this quadrant, make sure, that they're both negative. In the third quadrant, both the x and y are negative. Now, how do we find the sine? Is it our x, is it our y, or is it our y over x? How do you find the sine? It is the y value. So there's our answer sitting right there in the point. That is our answer. So the sine of 210 is negative 1/2. Let's go on to B. That is the cosine of pi over 3. That is 60 degrees. The 3 denominator should tell you that it's going to be related to 60 degrees. The point at pi over 3 is the flip of the one for part A. It is going to be the 1/2 comes first, the square root of 3 over 2 comes second. I'm up higher so that my y has to be bigger, so that's why the y is bigger for 60. And the 30, it flips them around. Now, in the first quadrant, everything is positive, so the x is positive and the y is positive. We want the cosine this time, which is our x value, so our answer is 1/2. Let's take a look at part C. The exact value of the tangent of 4 pi over 3. You'll notice our denominator is a 3. We are related to the exact point that we saw in section B, but it's in a different quadrant. Well, you might not recognize what the heck that is until you might convert it. Well, a pi over 3 is 60. 4 times 60 is 240. So I'm really asking the question, what is the tangent of 240? Well, 240 puts us into the third quadrant. Look at the point values you used for B, 1/2 square root of 3 over 2, except now they're both negative because they're in a different quadrant. So that is the point -1/2, negative square root of 3 over 2, -1/2, negative square root of 3 over 2. That is a 2 down there. And our question is, what's the tangent? Well, tangent is y over x, so we're going to take the y value and put it over the x value. So it's negative square root of 3 over 2 over -1/2. The negatives are going to cancel. The 2's are going to cancel. So you end up just with square root of 3 over 1, which is square root of 3. So the answer is square root of 3. Let's look at example 7D. The secant of 270. 270 is our quadrantal angle pointing downward. That is the point 0, -1. Think about what secant is. Secant is our reciprocal of our cosine. Cosine is the x. So the secant of 270 is 1 over the x value, or the reciprocal of our x value. We're not allowed to have 0 in the denominator, so it is undefined. Write undefined, or the null set is fine with me as well. Let's look at example 8. Now, the difference with example 8 is that these are not traditional ones that are on our unit circle. We have actually looped around too many times, or we are going to have to look for the coterminal version. So we're going to look for the coterminal version. So let's look at 9 pi over 4. We know it has a 4 in the denominator. We know it's related to 45 degrees. But which quadrant does it land us in? That's what you need to think about. Where is it going to land me? It is related to 45 degrees, but how? So you can do the trick we did on the 1 page, where you think, okay, those are 45-degree sections. That's a pi over 4 each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9 lands me back in the first quadrant. So 9 pi over 4 is coterminal with a plain old pi over 4. Well, why is that? Well, one rotation around is technically 8 pi over 4s. So if I take 8 pi over 4s away from 9 pi over 4s, I'm left with 1 pi over 4. That being said, the point at that location that we have to use to answer our question is the point square root of 2 over 2, square root of 2 over 2. However you get there, whether you find the coterminal angles, whether you draw a picture, whatever you do to get there. So the cosine is the x value. So the cosine of 9 pi over 4 is radical 2 over 2. That's why we needed to know what coterminal was, so that we knew if we landed in the same spot, we used the point that's there, even if we didn't get there in a traditional fashion. Let's look at part B. Negative 300. Well, where in the heck does that land us? Well, we learned that coterminal angles, if they are negative, we could just add on 360s until they became positive to find out where they're located. Well, negative 300 and positive 360 is 60 degrees. So negative 300 is equivalent to 60. If we were to draw a picture, here's 60. That's getting there the traditional way. Negative 300 gets there the backwards route. But it's coterminal. The point at negative 300 or positive 60 is the point 1/2 square root of 3 over 2. That is the point we're going to use to answer the question. Because it is coterminal, that's the value on the unit circle there. So the sine of negative 300 is the same as the sine of 60, which happens to be the y value, square root of 3 over 2. The answer is square root of 3 over 2. Let's do part C. For part C, it's a tangent of lots of pi over 6's. Pi over 6 is 30 degrees. We know it's related to 30, but how? Which 30 are we going to use? First quadrant, second quadrant, third quadrant, or fourth quadrant? Well, 29 pi over 6 is a lot of pi over 6's. 12 pi over 6's gets us all the way around. Why 12? Just double 6. It's two whole pi's would get us all the way around. So if we do 29 pi over 6's minus 12, we get 17. Still too big. Minus 12 again, we get 5. So 29 pi over 6 is exactly the same as 5 pi over 6. Now, if at any time you want to convert to degrees and use degrees the entire time, feel free. No, it doesn't bother me. But 29 pi over 6 and 5 pi over 6 are coterminal. They land in the same spot. 5 pi over 6 is something on our unit circle. Pi over 6 was 30. 5 pi over 6 is 5 30s or 150 degrees. So this lands us at the 150 degree spot. So we get to use that point. That point is coterminal with 30. The pi over 6 tells us that anyway. That is the point, negative square root of 3 over 2, positive 1/2. Negative square root of 3 over 2, positive 1/2. Now we have all the information we need to find the tangent of 29 pi over 6. So the tangent of 29 pi over 6 is the same as the tangent of 150. That's going to be the y value, 1/2, over the x value, negative square root of 3 over 2. So we know that our tangent is going to be negative. The 2's cancel out, so we're just left with 1 over radical 3. We want to actually rationalize that. So that pops a radical 3 to the top and leaves a normal 3 behind. So our final answer is negative radical 3. Let me write that a little better. Negative radical 3 over 3. Negative radical 3 over 3. Okay? So that's basically how we're going to use it. So I would suggest having your, screenshotting possibly your unit circle and having it like split screen when you're doing your homework so that you have it to look at and refer to. Eventually you want to try to get as much into your brain as possible for memory. The part that you want to do right now is the blue part. You should be doing what I was doing. I should see some conversions. I should see some little pictures. And then I should see the point where you got that location. And that would be the problems in blue. For the first section there, just look at examples marked with 2, 17 through 23, example 3, 25 through 30, example 4, 43 through 46, that's examples 7 and 8. Okay? So there is that assignment.